Well, good morning, good afternoon, good evening, everyone, and welcome to the world's most exciting classroom. My name is Joe Gorewski, and I'll be your host for today. We are into week four of the Oosterschelde's journey across the Pacific Ocean. Best way to show you that is with our map. So give me 1 second here to bring the map to the front. There we go. Let's make it a little bigger. So this will give you a little idea of what we've covered so far. Not too long ago, the ship was hanging out for the Christmas break for Christmas and New Year's in Christchurch, New Zealand. You can see it's been a weird pathway since then, and that's mostly kind of following pressure systems. So obviously a 7-week crossing of the Pacific, there's not enough fuel to just keep the motor running the whole time, and we don't want to do that. It's a beautiful historic sailing ship, so we want to be sailing as much as possible. So you can see we've had a few little bumps and detours along the way to kind of move around different pressure systems and try to use the wind as much as possible. If I zoom in a little bit closer, you can get a feel for where we are 4 weeks in. And then you can see where we're heading. Our destination is the Falklands. We have to round the Horn before we get to the Falklands. And I really, really hope that we're going to be able to take one of our satellite units and do something live in the Falklands, maybe in one of the big penguin colonies. We'll have to see what we can cook up over the next 3 weeks. And sometimes it's a little tricky getting permissions with bird flu and things like that impacting the area. But I hope within the next 3 weeks, we'll have a really cool announcement for something we'll be doing in the Falklands. Now, as always here on the map, if I turn the camera on here, we can take a look at some of the last clips from the ship. So here we go. This one's from a few weeks ago. A little bit of rocking in the waves. You can see this really cool dolphin here. This is a right whale dolphin, which was a really cool spot. I think Tom was mentioning last week, only 37 entries on iNaturalist, so they're not seen very often. You can see here we had a little bit of weather on the go, so you can see the ship moving along nicely under sail. You can see a bit of rocking, which probably made it a little uncomfortable for some of the passengers, the water washing onto the deck. And then the very latest update here, we've got a few more here. You can really see they had, I think, waves up to 7 meters at one point. You can see the water coming on the deck there. Everybody's bundled up in their gear on the deck. Yeah, so definitely some interesting weather as they enter the 50s on their way back towards South America. So the time zone's almost there. I think next week we'll be able to have a live connection from the Oosterschelde with Tom and Mara. But we did one more recording because right now on the ship, it's around breakfast time. Everybody's having their breakfast, just waking up. So we decided we'd do one more recording before we go back live from the ship. So I'm going to stop my screen share and share a video this time. And let's take a look at what we got up to chatting with Tom and Mara last night. Well, it is week 4 sailing across the Pacific, and they're getting closer to our time zone. I think they're just 2 hours behind now. So when we're live at 9 o'clock, it's 7 o'clock in the morning for them on the same day. So that's pretty cool. So we're going to catch up with Tom and Mara and see how the sailing has been since we caught up with them last week. So let's get them in here. A little bit colder today, Tom and Mara. How you doing?
All good, yeah. A little bit chilly, got a few more layers on.
Yeah. Yeah, and you're out of the 40s. You're in the 50s now, is that right?
Yeah.
Yeah, we crossed over last week. We actually made it down to 54, I think.
Yeah.
So we've just come back up to 50 actually, just sort of trying to dodge some low pressure systems that were maybe a bit too windy for us.
Yeah.
So coming slightly north again, but yeah, still in 50s.
So we hear the wind today. That must mean you have some sails up.
Yeah, definitely.
Yeah, I'll put a few up.
All right. Perfect. So what have conditions been like the last week? Have you been having to bare knuckle it at all, or has it been pretty so-so?
It's been a bit of a mix, to be honest. Yeah, we've had some calmer conditions, but then a lot of blustery winds actually. It's calmed down a bit today, but now it's starting to pick up again because tomorrow we're expecting some very strong winds, I think. They've battened down all the hatches and attached all the storm lines, so that'll be exciting for sure.
All right. So it sounds like you've got to enjoy the calm right now because 24 hours might be quite different.
Yeah, exactly.
Yeah. Well, last week, you guys conjured up some beaked whales for us right before we signed off. What do you have in store this week? What are you going to conjure up for us before we sign off?
Well, you never know.
Well, there's a bird.
There's a bird. There's a white-headed petrel right there.
Yeah.
Not quite
Yeah. Speaking of birds, have you made some good observations this week?
Yeah, we've had loads actually. We've had some new species again. So we've been seeing 2 species of prion. So we've had the Antarctic prion and the slender-billed prion. We've really seen before, so that's been really cool. And anything else?
We've had a couple grey-faced albatross, which we haven't seen too many of before, which are kind of cool.
Yeah.
The prions are particularly cool. They're tiny little birds that just manage to stay aloft in these crazy winds and paddle along the surface of the water. So
They're quite hard to spot when it's wavy like this because they fly so close to the surface. And you're looking through binoculars and you've got one, and then the big waves comes up and then you've lost it.
Yeah. And Mara, how much of your day would you say you spend on the bird survey?
Well, we try and do 2 hours each day, so 1 hour in the morning, 1 hour in the evening.
Yep.
As close to sunrise and sunset as we can manage it. And it just depends. We try and fit it around the watch system. So Tom and I are both part of the passengers watch system. So usually it'll be one of us doing it in the morning, one of us in the evening. So a couple of hours each day.
Yeah. Speaking of passengers, they're 4 weeks in right now. Is anyone going a little stir crazy, or is everyone handling it pretty well?
I think it's slowly starting to show a little bit. There's been a lot of dancing on deck, and people are maybe starting to go a little bit crazy, but yeah, it's not too bad yet. I think everyone's still having a good time, and it's very...
Well, you're past the halfway point, so that's something.
Yeah, and we actually passed Point Nemo as well a couple of days ago. So that's the point in the oceans furthest from land. So that was really exciting. We didn't cross right over it. We were a bit further south, but still, yeah, very remote.
And so Point Nemo is where they dump the spacecraft, isn't it? Isn't that where they try to aim satellites and spacecraft to come down?
I think the last time they did that was in 2001, but I was reading up on it, and there's about 230 different space objects just dumped in the water there, which is pretty nuts. And we were, I think the closest we got was 400 kilometers away.
Yeah.
Which is, the International Space Station orbits at 400 kilometers, so we were the same distance away as the space station, and being the closest humans as well. So
yeah, it's pretty crazy.
Pretty weird.
Yeah, very cool. What about wildlife? We know we saw that great video of the right whale dolphin. We saw some beaked whales, I think, last week. How's it been going out there?
There hasn't been too much in the past week. We saw some whales yesterday. I think they were some sort of pilot whale, but we were in the middle of hoisting the mainsail, so we didn't really have time, unfortunately, to stop and look. And I think you were down below, and by the time you came up, they'd gone, so we didn't get any footage. But there were, I think, at least 2 or 3 of them. Yeah, but apart from that, there hasn't been too much this week.
All right, very cool. Well, sounds like you've got a busy day coming up tomorrow. The water might be a little bit rough. Yeah, maybe by next week, we'll see if you guys cross another time zone. Maybe we can even get you live next week, which will be fun. We'll see if you hit another time zone.
I'm sure we'll have some wet footage to show you.
Yeah, we definitely want to see that. I don't know if you met Jesse, Tom. He was on board for the leg around Conception.
Yeah.
And he saw some of the footage you guys had posted on Instagram earlier and got sick to his stomach just looking at the footage. So I don't think he'd enjoy being out there with you guys right now.
Yeah, I think it's about to get worse.
Yeah. All right.
Yeah.
Perfect. Well, good luck out there. It's almost February. 2 more days till February. You're over halfway through, which is pretty awesome. And I guess the Falklands are starting to maybe feel a little more real as each day passes.
Can't quite see it though.
No.
It'll take a little while.
All right, very cool. Well, Tom and Mara, thanks so much for hanging out. Good luck tomorrow, and yeah, we'll catch up in a week and see how things went. Hopefully, there's some wet and wild footage for us, but hopefully not too tough for you guys.
Nice one. Thanks, Joe.
Right.
All right, thanks, guys.
See you later.
Next week.
All right, so there's a quick checkup with Tom and Mara. As you can see, 4 weeks into sailing, sounds like everybody's doing pretty well. If you look back at some of the photos, you can see they've been kept busy with things like laundry. Sometimes the ship looks like a big, maybe clothes rack full of clothes and sheets and stuff hanging and blowing and drying in the wind. But when you're at sea for 7 weeks, I don't think you can pack enough to bring. So you have to do your laundry on the deck. I have one more little clip here that Tom shared with me. Last week, we saw the beaked whales from Mara's phone, but Tom had his camera out and he managed to get a nice little slow motion shot. So let's take a look at this little piece that Tom sent me yesterday. There we go. The water is relatively clear. You can see the whale coming up. There's 2 others up top. And there we go. Very cool. Again, another species we don't see very much. We don't know a whole lot about. They hunt, they dive really deep. We record them on hydrophones, but it's part of the really cool thing about being out here in the middle of the Pacific is they're seeing some species of whales and dolphins that aren't observed very often. So that's pretty cool. And yeah, we'll leave it there with the ship for now. They've still got 3 weeks to go to get across the ocean. And with any luck, we're going to have that connection with them. And then what I thought was really cool was they were really close to Point Nemo, which is pretty much the most remote part of the Pacific Ocean, as far from land as you can possibly be. And hundreds of different space artifacts from space stations to satellites. They aim to have them crash there into the ocean. So if any pieces don't burn up in the atmosphere, they're going to land as far away from land as possible. And that'll likely be the resting place several years from now of the International Space Station when it's no longer usable. So we're going to have a little catch up with some Explorers Club researchers. I want to share something really quickly here on my screen. Where is it? There it is. You guys may remember Chris Hall and Tim Land. They joined us. Oops, where did my share screen go? Let's try that again. Okay, maybe I won't be able to share. It looks like it's acting up with me right now. That's okay. Okay, so you guys might remember Tim Land and Chris Hall. They were our Explorers Club researchers in Tahiti when we did that big circuit through some of the islands, and they were using drones to observe and map coral reefs in the area, spots that had never been kind of surveyed in this way before. So let's get Tim and Chris in here with us right now. Hey, Tim. Hey, Chris. How you guys doing?
Hey, Joe. Good to be back.
Yeah, good to see you. Tim, I know you're in New York. Chris, where are you right now?
I am in Cambridge.
Okay.
In the UK, not Massachusetts.
All right. Very cool. So, yeah, you know, for the classrooms who are joining us and maybe haven't met the two of you before, do you each want to take a minute and just introduce yourselves? Tim, why don't you start?
Yeah, so I'm Tim Land. I'm currently a PhD student at the University of Oxford studying engineering. And I also do some work in international development with USAID, the UN. Yeah.
Yeah, so my name is Michael. I'm a PhD student in engineering at Oxford. But I'm just finishing up my PhD now, so have started working full-time on designing electric motors at a startup here in Cambridge.
All right, very cool. Well, you guys had a pretty cool experiments and research you were conducting. Who wants to tell us a little bit about what you guys were up to while you were in Tahiti?
Yeah, so our goal was basically to collect data for the researchers there to help them map the trajectory of recovery for coral reefs from bleaching events. And doing that with drones kind of allows you to collect a lot more data than if you were swimming underwater, just human powered, but also allows you to collect finer resolution data than if you were to try to collect it with satellites. So it's kind of a good midpoint there for collecting a decent amount of high resolution data, so that you can really see like the details on the corals and get into the nitty gritty of how well they're recovering and how well the ecosystems are doing. So there were a few kind of target hotspots around the Society Islands where we sailed that the researchers that we were working with were interested in. Those researchers were at a lab called CREOB, which is situated in Moria, which is kind of like the second most populated Society Island after Tahiti. It's right, it's next door neighbor. So they gave us a few sites to go target. So then we went there and took a bunch of images with the drones.
Yeah.
Yeah.
And the drones, did they have to be modified in any way, or were they pretty much usable for this, commercially right from the purchase?
Right out of the box, Joe. It's great. Yeah.
Yeah. Very cool. Well, I know from experience and from being out on the ship and trying to fly drones that it's not always easy. Did you guys have any challenges when you were trying to collect the data you needed?
Yeah, so the biggest challenge is actually weather. So the ship is only going to be in a certain spot for not that much time usually. Like it's on a schedule, it's got to get to the next place. So Joe, we were super concerned about the weather being inclement when we were in the spots that we wanted to image, but we got actually quite lucky with that. And even so far as one day when we were on Bora Bora, we didn't do any imaging directly from the ship. We would kind of go on land and do it there, which makes it which is sort of an easier base to do it from. Yeah, you're right. If doing it from a moving ship is a whole nother beast altogether. But yeah, there was one day on Bora Bora where we had made all the plans to go in the morning to a certain spot to take images and like organize to transport to and from the ship with the crew, and a storm just blew in and we weren't able to go. But then it was supposed to be stormy later in the day, but then it turned out it just sort of randomly cleared up right around sunset, which was perfect for us to go and actually collect some images at the spot we wanted to go to. And one thing I should mention, Joe, is that for our purposes, you could only really take images at sunrise or sunset, because if the sun is too high in the sky behind the drone, it causes a lot of coolant off the water.
Yeah.
So if there's too many waves, or if there's too much glare, then you can't really get good images. You can't really see underneath the waves or underneath the water, rather. So we got our perfect calm after the storm, as it were, that evening. But yeah, it was a bit dicey the whole time. We weren't sure how many images we were going to get.
Yeah, that's kind of the fun of an expedition, is you come with all these plans, but expeditions have a way of just changing everything. And you can have the perfect plan, but it can all change very, very quickly. Tim, what flying the drones? I know you can see the coral, but I think you guys saw a little bit of wildlife as well with the drones.
Yeah, we were able to get some really cool pictures of different sharks and fish. And we know that that's something that CREO was specifically interested in testing out the drone methodology for, is how it could be used for different wildlife surveys, also with giant clams, kind of species density around giant clams, which is interesting. One of the things that I've been reflecting on post-expedition is just how cost-effective drone methodology, using drones to survey for conservation is for research institutes, and in a world right now, and will continue to probably accelerate and exist, where funding for conservation efforts and anything kind of climate related is, especially in the US, threatened right now, that cost-effective methods like drones are going to be increasingly important. So we feel like that hopefully what we did and what we will continue to do will stay on the cutting edge of that.
Yeah. And so you guys, I believe you went a little bit early, and did you stay a little bit afterwards? What were you up to in between your time on the ship?
So we were there a week early, and the intention of that was to actually liaise in person with the researchers we were working with at CREOB and the University of French Polynesia, as well as do some test flying. Always flying a drone like that in a new country is always, you kind of want to have some, get some testing done, because sometimes some no-fly zones or something like that pop up where you weren't expecting them, which actually kind of happened to us when we were on Tahiti. So that was good that we got that all squared away beforehand.
Yeah, drone rules in different countries can be a lot of fun. Just recently, I've been getting ready for Cape Town, so thinking about those rules, and then the UK as well for when the ship returns to the UK in July 2025. So yeah, you always have to be brushed up on those drone rules.
Yeah, let me know if you need another pilot in the UK. I've got pilots here, so.
Well, we'll definitely have to have. Cambridge isn't too far from London. The ship will make its way to London for a celebration, so we'll definitely have to have you come join us for that.
100%.
Cool. So, okay, you guys have collected this data. What is the fate of that data? Have you had a chance to kind of look at it? Are there other groups who want to get their hands on it? What's it going to be used for now?
Yeah, Tim, do you want to, or should I, or?
Yeah, so the data is sitting in the hands of CREOB and the Oxford Seascape Ecology Lab right now. We messaged both labs to kind of try and get an update quickly to share. Unfortunately, I think people are still kind of easing into the new year. So we don't have a technical update on kind of continued progress of how the research is progressing. We'll share that when we get it, because we know CREOB is actively working on it. But generally, these sorts of things take years, not months, to kind of process and get rolled out. So we would love to share the data with any other groups that are watching this and, are interested in talking to us, or, seeing how they can use our data to help their research. So we're always open and here to talk with other groups.
And it's great baseline data, right? So somewhere like CREOB, they can go out a year or two, or even a little bit further down the line, and then they've got that comparison. They can see how things are changing. Is there growth coming back? More bleaching events? So
yeah, and there's a postdoc at CREOB right now who is actually who will do exactly that. Next year, we'll go back to the same places that we went and do the same sort of surveying to measure those sorts of changes if they're there. So at least one we know of.
All right. Well, before I let the two of you go, we're always interested in connecting with our Darwin leaders as well as our Explorers Club researchers to see what's next. So looking ahead to 2025, what's on the horizon for each of you? Why don't you start, Chris?
So I think Explorers Club wise and expedition wise, we're definitely interested in continuing to do similar kind of drone based research. So yeah, Tim and I are looking at some expeditions coming up where we can hopefully contribute our sort of drone capabilities and data collection capabilities. I don't think we have anything on the books for 2025, but probably in 2026 for sure. I think, Tim, more details about that.
Yeah, we were talking about a specific expedition that we would kind of tentatively planned, but unfortunately Chris and my schedules didn't quite align perfectly with it. So, but yeah, it was a similar type of expedition as the Darwin, just applied more to glaciers, kind of a similar type of conservation drone-based methodology. So that's kind of what we have our eyes on next, is continuing to expand. How can we further expand the drone methodology to do other sorts of conservation monitoring? So we're actively looking, we're actively planning, but nothing firmly on the calendar yet.
All right. Well, thanks, guys. It was great to connect. I'm sure, Tim, you're probably experiencing what I am here. We have lots of snow. I don't know what it's doing in New York, but it's cold here. Definitely not like those nice waters of Tahiti where you guys got to spend a few weeks.
How about those waves that we're seeing? It really makes our time in Tahiti just look like an absolute breeze. So shout out to all of the people watching from the boat. I mean, you guys are pro sailors compared to us.
Yeah, they're definitely getting a nice little crash course in Pacific Ocean sailing. Yeah, pretty wild.
Well, thanks for having us, Joe.
Yeah. All right, guys. Well, thanks so much for joining us. And we still have about 5 months to go. So maybe we'll connect again before the end of this 2-year Darwin 200 journey.
Sounds great. Hopefully we'll have some more technical results next time we chat.
Awesome. All right. Thanks, guys.
Thanks, Joe.
Thanks, Joe.
See you later. All right. Perfect. Well, great to connect with some of our Explorers Club researchers. We have another one coming up, Haley. She will join us in the coming weeks, and she was doing some eDNA work. So for those who don't know what eDNA is, environmental DNA. We can take samples of things like water and soil, even the air, and then we can see what's passed through it recently. So wildlife doesn't always cooperate. You don't always see everything that's there, especially below the surface of the ocean. But collecting the water samples and then analyzing the DNA found within, we can get an idea of what's living in that area, what's passed through. And so ever since New Zealand and Fiji, we've been taking eDNA samples around the ship, on land, and then in the water. I know Mara and Tom have done several over the past few weeks, collecting them from the water. So we're trying to get a nice picture all the way across the Pacific, then across the Atlantic and up along the coast as we make our way back to Falmouth in the United Kingdom. So let's take a little look at what's coming up in the rest of today's World's Most Exciting Classroom. We're going to take a look at the answer to our geologic time experiment. So that's coming up. We'll have another experiment for classrooms to try around ocean acidification. We've got our curiosity of the week to look at, as well as a brand new one. And then I also have a really cool interview tour that we did at Taronga Zoo while we were in Sydney, Australia. So Taronga Zoo was one of our conservation partners. We had the honey eaters, and we also had the corbury frogs. And so I was able to visit where they have a breeding program for the frogs. And this breeding program represents about half of the species of half of the frogs still in existence. So programs like this are really important arcs. And we're going to take a look at that little video tour that we did while we were in Sydney. So let's start off with our geologic time experiment. I'm going to share my screen, and in a moment, it should fill yours.
Welcome back, everyone. Last week, I asked you to measure out 4.6 meters of length. I've used this measuring tape, but you can also use string or rope to the distance of 4.6 meters. This represents the timeline of Earth. Earth is 4.6 billion years old. So every meter along your timeline represents 1 billion years. Every 10 centimeters is 100 million years. And every single millimeter is 1 million years of Earth's history. Your task was to place along the timeline these key milestones in Earth's history. When do you think these key milestones happened? Well, let's now find out. So on my timeline, the start of Earth's history is over here. I'm afraid this room isn't quite big enough, so I've had to curve my timeline here. But hopefully you have enough space to lay out your full 4.6 meters of Earth's history. The first milestone concerns the point at which the very first evidence of life on Earth becomes apparent. Where in the timeline do you think this milestone arises? Well, the answer is about 750 million years from the start point. So that's 75 centimeters along our measuring tape. That's about 750 million years from the start point. So on my timeline, that's precisely here. It's pretty amazing to think that the first fossil evidence of life on Earth is dated to 3,850 billion years ago. And that's that point right here. It may be possible that life actually existed earlier and just simply isn't apparent in the fossil record. But that's generally the point that most authorities agree that life was definitely existing on our wonderful planet. Our next milestone concerns when the first animals become apparent in the fossil record. Remember, the grouping of animals doesn't just include birds, mammals and reptiles, but rather can consist of single-celled animal life as well. At which point did you decide the first animals become apparent? Well, the answer is way over here. It's at 390 centimeters from the start, which is right here. Believe it or not, this is where the first animals become apparent in the fossil record. Look at that vast expanse of the timeline during which there were no animals present on Earth. The next milestone concerns the point at which the first land plants become discernible in the fossil record. Note that up until this point, all of the life was in the water of the planet, in the oceans and seas. But at what point do you think plants moved on to land? Well, the answer is at 410 centimetres from the start. This is 4.1 billion years into the timeline, right over here. This is the point at which the first evidence of land plants becomes discernible. It's pretty amazing to think that that was just 500 million years ago from the present day over here. Our next milestone concerns when the first animals moved onto land. And that took place relatively soon after the plants, at here, at 420 centimetres from our start point. That's about 4.2 billion years since the formation of the planet. And that's about 400 million years ago from today. The next milestone is a very important one. It's the emergence of the very first mammals. This took place at around 440 centimetres from the start point, or 4.4 billion years from the formation of the planet. So that's about here. We'll put our first mammals here. They were mostly small shrew-like creatures that scurried around. And this is only about 200 million years ago from the present day. The next milestone is the extinction of the dinosaurs. The dinosaurs became extinct about 65 million years ago. So that relates to 4 meters and 53 centimeters on the timeline. So right about here. Look, we're getting pretty close to the present day. I'll put that one right there. And the last milestone is arguably the most important, at least from our perspective, because it concerns us. When do you think our species, Homo sapiens, emerged in this timeline? Well, the answer is that fossil records of Homo sapiens stretch back just 200,000 years. That would be in the last fifth of the last millimetre of this timeline. So right over here. It's so close to the end, I really can't mark it on. Our entire history as a species would occupy the space of just a few human hairs on this 4.6 metre long timeline. Just stop and think how recent we occurred on the planet and how tiny a part of Earth's history we really are. Just step back and look at your timeline. What does it teach you? Clearly, most of the key milestones in Earth's history are over here, close to the present day. Look at this vast expanse of time, literally 3 billion years since the beginning of life on Earth, when nothing existed except very simple organisms, generally single cellular life. During this enormous expanse of time, these 3 billion years here in the middle, life slowly accumulated. Oxygen was produced, changing the Earth's atmosphere, and gradually it became more and more complicated over this immense expanse of time. Well, how did you get on? Did you find the correct positions for the different milestones in Earth's history? Or did you think these different milestones occurred much earlier along the timeline? I wouldn't blame you if you did, because it's astounding how recent all of the key developments are in relative terms in the history of our planet. If there's one thing you take away from this experiment, it's the incredible age of the planet and the humbling reality that our brains simply didn't evolve to understand the concept of 1 million years, let alone 1 billion years. Thank you for taking part in this timeline experiment, and I hope you've enjoyed exploring the astonishing history of our wonderful planet. Now let's find out who won this week's prizes.
All right. So very, very cool. That's one of my favorite experiments we've done recently. There was also how big is the solar system. So if you go back to the Darwin200 YouTube channel, there's a playlist for experiments. And I think this one with the geologic time, where you really get to picture how much time has passed and those kind of key milestones on Earth, and then how big is our solar system, is another really, really cool one to help you visualize just how much space there is from the sun all the way out to the extent of our solar system, out past our dwarf planet Pluto, out to the kind of sphere of comets, the Oort cloud that kind of surrounds our solar system. The sizes get just wild. So how big is our solar system, along with geologic time, I think are two of the coolest experiments we've done in 2024, that's for sure. Okay, so we are going to have a new experiment this week. It's an experiment similar to one that we did back in 2023 when the ship first sailed. We're sailing across a big expanse of the ocean. We just talked to Tim and Chris, who are looking at coral, and we know coral bleaching is something that's impacting coral reefs, but there's also ocean acidification, which is having an impact on coral reefs, and it's also having an impact on marine life, especially marine life that has shells. So this experiment is looking at ocean acidification. It's a really easy one you can do in your classroom. The supplies you need are very, very small and easy to get your hands on. And then, of course, we want to see some pictures trying it in your classroom. So let me share my screen. Let's take a look at this one together.
Do you know what your bones are made out of? They're made of calcium carbonate, in common with animals right the way around the world, from birds to butterflies. Calcium carbonate is especially important for marine life because it's soluble, so it dissolves in water. That makes it very easy for marine organisms to absorb it into their bodies. So animals from crustaceans to mollusks to corals use it for their exoskeletons or their bones. Unfortunately, a big problem today is that the pollution that we're creating is increasing the acidity of the world's oceans. This is a problem because calcium carbonate reacts with acid, so it has an impact on the life that lives in the world's oceans. Today's experiment is going to explore that very subject. For this experiment, you need about 200 millilitres of white vinegar. This is available at supermarkets across the world. It's also known as acetic acid. It's used for cooking purposes. Your parents might have some at home in your kitchen, or maybe your teacher has got some in the science lab at your school. Be a little bit careful because this stings if you get it in your eyes, and it also doesn't taste very nice. So wash your hands after doing this experiment to make sure you don't get in contact with any of this vinegar. You also need about 200 millilitres of water. This can be seawater, rainwater or tap water. The purpose of this is to use it as a control against the vinegar to check your results. You also need some seashells. Hopefully some of your classmates have been to the beach recently or on holiday and collected some shells that they can spare. Ask your teacher for some pH strips to test the acidity of the vinegar and the water. And then you also need some scales to measure the weight of the seashells before and after the experiment. Okay, let's get started. Step 1, measure the weight of a shell. This particular one here weighs 6.6 grams. So we'll put this in a beaker labelled vinegar. That's right, 6.6 grams on the front of it. If you want to, you can put in other shells, but just remember to make sure that you know which shell you've weighed. So I'm going to put in lots of little shells, which are different from that big one that we just weighed. Then just repeat the process for water. So let's put this shell in our beaker for water, and this one weighs 5.8 grams. So this is a little bit smaller. The difference doesn't matter at all. Let's put that one in here. We'll add a few small shells as well. Step 2, we've got to measure the pH of the two different liquids and see how acidic they are. So here's a little pH strip. Let's put it in the vinegar. Well, look, that's turned bright orange. If we then compare that against the pH colour chart, look, we can see that's easily pH 4, even maybe getting towards pH 3. So it's very acidic. Let's repeat the process for the water. Oh, that hasn't changed colour at all. Let's compare that against the colour chart. Yep, that's pretty much neutral. That's about pH 7. So that's not very acidic. So we've got a good contrast between our two liquids. Step 3, it's time to do the experiment. So very carefully take your vinegar and pour it onto the shells. If you wait a couple of seconds, then look really carefully, you should see something happen. Then our control experiment, let's pour in the water and see what happens there. You then have to be really patient and leave the two beakers alone. But if you look very, very carefully, you'll see something is happening. After waiting 24 hours, it's time to take the shells out of the liquids. Let's start with the one in vinegar. So put that on a paper towel and dry it very carefully so it's completely dry, because the weight of the liquid can impact the experiment. And then you've got to measure its weight again. So this is now saying it is 5.4 grams. So if you remember, we weighed that shell and put it in, and it weighed 6.6 grams. It now weighs 5.4 grams. So it's reduced in weight by 1.2 grams. Let's do the same for the shell that we put in water. It was this big shell down here at the bottom, if I remember correctly. Here it is. Let's dry it again. And let's weigh it. This shell is 5.8 grams. So it is exactly the same weight as it was when we put it in the water. It's 5.8, so it hasn't changed at all. So one shell has reduced in weight, one shell hasn't. Why do you think that is? So the shell that we put in the acidic vinegar has decreased in weight. However, the shell that we put in water has stayed exactly the same. Discuss your results with your teacher or your parents and try and answer 3 research questions. You've got to upload the answers to these 3 questions to our website within the next 2 weeks in order to win prizes. The first question is, what's happened and why? Why do you think we've seen a difference between the 2 shells? Remember, there's a difference in the liquids that we put them into. The second research question is, what do you think the gas was that was released from the shells? Remember all those little bubbles? What was that gas? There's a clue in the words calcium carbonate. Discuss this question with your teachers or your parents at home. And for the last question, think what impact increasing the acidity of the world's oceans has on marine life. Those crustaceans, mollusks and coral. What impact would the increasing acidity of the world's oceans have on the calcium carbonate of these organisms? And what can we do to reduce the impact of ocean acidification? Upload your answers to the DARWIN200 website within the next 2 weeks for the chance to win exciting prizes. Remember, an instruction PDF can be downloaded from our website. Good luck, and see you in 2 weeks for the answers.
All right. So, new experiment, 2 weeks to give it a try in your classroom. Stu left the shell in the water for 24 hours and then took measurements, but you could wait 2 days, 3 days, a week. You could try different days and see what the change is. And then we have those 3 questions to try and answer. And the best way to get those answers in is classroom@darwin200.com. So answer those 3 questions and send them in an email to classroom@darwin200.com. And be sure to include a photo of your class trying the experiment. As always, the experiments can be tried at home as well. And you can send in your answers and pictures from trying the experiment at home. So before we wrap up with our curiosity of the week, I did mention that we made a video when we visited Taronga Zoo, and we had a tour of the breeding facility for the coral reef frogs. So these frogs are very endangered. There's probably only a few thousand left in the wild. And so this program at the Taronga Zoo really is an arc to keep the species alive, to then return them back to the wild. But there's also an important aspect of making sure where they're being returned is being protected and safe as well. So we met Mike at the lab, and he gave us a really cool tour of this facility. And we have a completed video of that tour here for you to check out.
I'm Michael McFadden. I'm a Wildlife Conservation Officer here at Taronga Zoo, Sydney, where I focus mostly on reptiles and amphibians and threatened species. Today, at the moment, we're in our Northern Coral Frog Conservation Facility. Here we look after one of Australia's most iconic frog species, the Northern Coral Frog. It's a critically endangered species. It's only found in Australia. It's only found in a very small portion of Australia in the mountains at our highest elevations. And this species, unfortunately, is down to less than a couple of thousand left in the wild, and relies on conservation facilities like this one right here for its continual existence. Here in this facility, at the moment, we have about 600 northern coral frogs, which is about maybe between half and a third of what's left in the wild. So here we capture a great proportion of the genetics of this species here in this facility. So the species we have here in this facility is the northern coral frog. It has a closely related cousin, the southern coral frog. They both look pretty similar. They have similar kind of patterns, but you'll see on this frog here, the yellow is a little bit more kind of towards lime green. It's got a bit of green in the yellow. The southern coral frog, on the other hand, has a bright yellow coloration. So they're very similar frogs. They only look a little bit different. They both occupy the same kind of habitats, and they're both impacted by chytrid fungus the same, unfortunately. In the wild, the northern coral frog's down to the last couple of thousand individuals. The southern coral frog is even more at risk. The southern coral frog, at the moment, the only sites it occurs at in the wild is our reintroduction sites. So the species would actually be extinct without the conservation breeding programs being utilised to supplement wild populations, and also to release frogs with our partners, our New South Wales threatened species officers, into disease-free enclosures down in Kosciuszko National Park. In the wild, this species occupies habitat at high elevations. Some of our more higher elevation sites in Australia. This species is found up at elevations that are between usually about 1,000 and 700 metres elevation. So in Australia, that's some of our highest peaks. Australia is a pretty flat country, but at those elevations, that's where we get snow throughout the winter months. And this species is actually found during the winter months, is found under the snow. They chill right down, and this facility here, being an insulated facility with refrigeration on it, we drop this facility down to about 4 degrees Celsius during the winter months, which means effectively this facility becomes a fridge. It's actually like a big walk-in fridge. The frogs bunker down. They won't eat for that whole period. They won't eat for about 3 months. They disappear into the moss, and then they come back up again as soon as we start turning the temperatures up, and that's when they start feeding again. Now, the reason that this species is endangered in the wild, there's a few different reasons. But the primary one driving this species towards extinction is a disease. It's called chytrid fungus. It's a disease that's present in Australia. It's present in the Americas. It's actually spread all around the world, and it's wiped out about, we think, between at least 50 species. It's caused the extinction of, and there's hundreds of species that it's impacted on greatly. And unfortunately for this species, the northern coral frog, they have very little resistance to the disease. So when they get it, they get quite sick. Their little hearts stop beating because of the electrolyte balance in their system. So their sodium and potassium levels drop, their hearts stop beating, and unfortunately they die. For the northern coral frogs, there's a couple of other threats too. One you may have very well heard of in the past is climate change. For this species, they lay their eggs in little moist terrestrial nests, so moist nests on land, not actually in the water. And they rely on the early snowmelt or autumn rains to flood those nests. In dry years, when it's dry and hot, unfortunately those waters don't come, so often the eggs or the tadpoles dry up and die. So these days we're getting more and more extremes, extreme droughts and extreme flooding, and unfortunately for this species, during those years, sometimes no eggs get through tadpole stage to metamorphosis. So climate change is another threat to the species, and there's other things too, like introduced species such as deer and horses, pigs, there's invasive weeds, but disease and climate change are two of the big factors for this species. And unfortunately, with increasing fires The bushfires that we had in Australia back in 2019, 2020 is one of the reasons we actually built this facility. When the bushfires happened, the remaining populations of the northern coral frog were under severe threat. About 70% of the remaining, so 7 out of every 10 populations remaining of this species got impacted by the bushfires. Hence, we got funding to build this facility. We started up setting up more of an insurance colony for this species. And now we're in a position where we've got a really broad genetic range of this species. And we're able to breed them here at the zoo for reintroductions back to the wild to try to bolster wild populations and get this species surviving and breeding on its own again. Now, if we look around this facility, there's a few different things you'll see. You'll see lots of these little containers, and every one of these little containers is full of frogs. And in some of these containers, like the one I'm opening right now, in this little container, you can see 4 little frogs in there. Those frogs in there are 20 years of age. So these ones were bred at the start of 2005. So they're 20 years old. This species can live for some time. They can live for, well, I guess, as far as we know, at least 20 years in the wild. 20 years at the zoo, sorry. In the wild, we know they live for about 9 or 10 years. But here at the zoo, frogs that are over 20 years old are actually still living and breeding now and still nice and healthy. So in the absence of disease, with lots of food available, with the best care that they receive here at the zoo, they're able to live and thrive to a much later age. So in all the middle tanks you see behind me here, there's about 50 to 70 tadpoles in each of those, and they're ones we're rearing through. They're ones that were bred here at the zoo, and we're rearing them up for reintroduction back to the wild. In the top and the bottom tanks are ones where we've collected eggs from different sites in the wild. We're actually rearing them here to contribute towards the insurance population. So all of the insurance population here at the zoo comes from eggs that were collected from the wild initially. We've never actually collected frogs, we've just taken a small proportion of eggs from different nests from throughout the range to closely genetically manage the species and make sure we've got a really broad mix. For a species that's on the brink of extinction, the more genetic diversity you have in the population means the more options they've got to evolve and adapt long term. They'll be able to produce resistance for disease on their own. They'll be able to adapt to changes in the climate and so forth long term. So we have a good genetic range. Here in these middle tanks, the tadpoles that you see in the image, these little ones here were bred at the zoo, and we're rearing them up to metamorphosis. You can even see one of those little ones in the back there. He's actually developed his front and his little back legs, so he'll come out of that tank over the next day or two. And then these little ones will be reared up to about 1 year of age, and we'll reintroduce them back to the wild. We do have an active reintroduction program for this species. We've done everything in an experimental fashion. So we've done releases of different life stages, so of eggs, of juvenile frogs, of adult frogs, just to determine what technique works the best. We've also released them in different seasons, so we've released some frogs in spring and some frogs in autumn, just to determine what frogs survive better. And every time we release these frogs, the frogs with their colourful pattern that you'll see in the images and the footage of them, they've got beautiful yellow and black stripes, and their belly's got yellow and black blotches, but each one's like a fingerprint. So each frog is individually, we're able to tell them apart. So of all the 600 frogs in this facility, we're able to tell them all apart quite readily by their pattern. So when we release these frogs to the wild, we take photos of their back and their belly, and then years later, when I find them on the nest in the wild, when we're doing our monitoring, I can actually work out, this one was from the spring release of 2014, or this one was from an adult release in 2020. And that allows us to fine-tune the technique to make sure we get the best reintroduction, the best survival from reintroduction as we can, to give this species the best chance of surviving in the wild long term that we can. So in these little tanks, we've been pulling out the little tadpoles as they develop their front legs. At that stage, they're going through metamorphosis. And when they go through metamorphosis, the tadpole fully physically changes into a frog. It develops legs, it loses its gills and develops lungs, it loses its suctorial kind of mouth part disc and develops an actual carnivorous little mouth. Its whole digestive system changes from a long vegetarian digestive system into a short carnivorous gut. So they go through that process of change. But in that process, they need to be able to climb out of the water. So we put them in these little tanks, and then over the next kind of 4 or 5 days after they develop their front legs, they'll climb out into the gravel and up into the moss. And there they'll go through their full stage to metamorphosis, and then after that point, they'll be transferred to one of our little terrestrial tanks where we'll start feeding them up, and they'll go on their growth journey. At metamorphosis, this frog is only about 0.15 of a gram, so they're a tiny little frog. They fit on your finger, on the back of your little finger's fingernail. They're a tiny little frog when they first metamorphose, and we have to feed them tiny little day-old crickets for them to eat because they're that small at that stage. And then it'll take them at least 2 or 3 years before they're at a stage where they're big enough and old enough to actually start breeding and producing eggs of their own. So here at Taronga Zoo, we're a not-for-profit organisation where our main focus is on conservation. We have a whole range of recovery programs that we participate in. We fund different conservation programs around the world. And just here in the department that I'm focusing on at the moment, the Reptile and Amphibian Department, we have 7 different conservation programs for species that are on the brink of extinction, some species that are extinct in the wild, and others that are critically endangered and down to their last frogs. For some of the species we work with, there's one in particular here at the zoo, the yellow-spotted bellfrog, which at the moment only exists here at Taronga Zoo. We're breeding them up at the moment for reintroduction to the wild. We have other species like the Bellinger river turtle that crashed really heavily in 2015 due to a new disease. We set up an insurance population, and we have individuals of those eggs being laid and hatchlings hatching out as we speak, which are going to help save the species. And even on Christmas Island, which is an island off to the north of Australia where 2 species of lizard are extinct in the wild, we've got them in here at the zoo, as well as a breeding population on the island, and we're breeding those up for translocation to try to bring those species back from the brink. So here at Taronga Zoo, our main focus is conservation, and one of our main focuses is focusing on those species that are right on the brink and needing human intervention to get past. Without the breeding programs that you see, unfortunately, some of these species will be lost forever.
Okay, so it was really a treat to be able to visit the zoo and to visit that facility. You can see it's really just kind of a large refrigerated shipping container, but they've used the space to set up a program, 600 frogs there, representing about half of the wild population. So really important programs, multiple different species of amphibians being conserved this way at the zoo, including some that have gone from the wild. And they're only existing in captivity. So zoos, of course, are a great place to visit and see animals. But by doing that, you're supporting really important conservation work. And zoos really act as an ark for endangered and threatened species around the world. So to wrap up, we have to talk about last week's Curiosity of the Week. I have it here with me right here. This week's Curiosity, we had some great guesses from classrooms. And it is, in fact, a whale vertebrae. So this particular fossil of a whale vertebrae is 4.4 million years old. And this fossil came from a place called Aurora in North Carolina. So you can see it's a fossil vertebrae. Many classrooms got this immediately. It does have a very distinctive shape of a vertebrae. You can see there where there's other pieces broken off there. But yeah, this is a fossil whale vertebrae. And I have to give a shout out to, let's see, Miss Lightbourne's crew. They are in Nova Scotia in Canada, and they guessed right away this is a whale vertebrae fossil. So we're going to send your class a Amazon gift card. Miss Roll's class in the UK sent in a guess as well. They were really close. They got that it was a fossil vertebrae, but they thought maybe it was a dinosaur. But no worries to Miss Roll's class. If you are tuning in, you had the correct answer to last week's Curiosity, which was a meteorite, and we have a gift card for your class as well. So keep an eye out over the weekend. You should see those gift cards being sent as an email to your classrooms. So we have a brand new Curiosity for this week for your classrooms to try and decipher what it is. Then you have 1 week to send us in an answer. And here is this week's Curiosity. So it's a little bit maybe hard to see with the camera. Let me see if I can get closer, if it'll focus. That's not too bad. So this is this week's Curiosity of the Week. It wouldn't be found naturally in this rectangle shape that I'm holding right now. So this was found and it was cut to this shape. So I'm wondering if you guys can take a guess at what this Curiosity is. I'm going to eliminate something for you right away. It is not a piece of wood. I know it might look like a piece of wood, but I will eliminate that from your potential guesses as to what this week's Curiosity is. And I'll even give you a little closer look. I took a little video of it as well. And maybe this video will help as well to get a nice close look at what this week's Curiosity is. So you have 1 week to have a think about what this Curiosity might be. And then you need to send your answers to classroom@darwin200.com. Classroom@darwin200.com. Send us your best guess and we'll pick a classroom to win a $50 Amazon gift voucher. So 1 week for the curiosity of the week. All right. And then, of course, you have 2 weeks to try that experiment, ocean acidification. Send in your answer to those 3 questions, plus a picture of your classroom giving that experiment a try. All right. The last thing we need to do today is to give a shout out to our sponsors, to our supporters. Thank you so much for allowing us to sail around the world, to have the world's most exciting classroom, to do the research that we're doing with our Explorers Club researchers, as well as bring our young Darwin leaders from around the world into the ports to work with various conservation organizations and to gain valuable skills and tools for their future careers in conservation. We couldn't do it without you. So thank you so much to the classrooms who joined us today. Thank you to those who will be tuning into the recording over the coming few days and into next week. And we will be with you again next Thursday, 9 o'clock Eastern, 2 p.m. UK time for the next World's Most Exciting Classroom event. It'll be our 70th World's Most Exciting Classroom. We will have a live connection from the ship. They should be close enough to us that we can go back to live connections, which are always fun. We can tour the ship a little bit more, see some of the science going on. And who knows? Last week when we were doing the recording, we had those beaked whales turn up. You never know what you'll see in the middle of the ocean. So thanks so much, everyone. And we will end off with a shout out to our sponsors and our supporters and our partners.